All right, we are live with our first of two Hangouts this week. Today we will be live with Scott Wlaschin, who will be doing his Community for F# Heroes interview, followed by a quick Refactor with F# session. And then tomorrow we'll be visited by Yan Kui. We'll be actually live streaming the F# Bristol meetup tomorrow night in the UK, which will be about lunchtime for those of you in the States. But today we have Scott, and we are excited to have him. Scott is a board member for the F# Software Foundation and runs the F# for Fun and Profit website, which I'm sure most of you are familiar with. Scott was also selected as one of our 2015 Community for F# Heroes. And so as way of introduction today, I wanted to just go ahead and jump into the interview with Scott. So Scott, thank you for joining us today.
Thanks so much. It's a pleasure to be here.
And the first interview, the interview question is, what was your first computer?
Okay, so I'm pretty old, so this is a bit of a blast from the past. It was a K-Pro. Actually, it wasn't my computer, it was my dad's computer. And it was a K-Pro, and it had two 5-inch floppies, 5¼ inch floppies, and no hard drive. And it ran CP/M. And that was very exciting because you could actually, it was running things like WordStar and DBase and stuff. And the nice thing, actually the first programming language I used was on that computer, and it was DBase 2, which was a kind of little mini database, kind of like Access or Clipper or one of those things, or FoxPro, you know. And it's actually really good, a great way of getting into programming. I actually think those integrated things where there's a database and a screen and all you have to do is kind of connect the dots with a couple of lines of code is actually a great way of getting people into programming. And then the first computer I bought with my own money, I think, was a 386, maybe it was a 486. And that was like, I remember there was a cover of Bytes magazine and it said, is the 486 the most powerful computer you'll ever need? Nobody will ever need a more powerful computer than this. So, and it had, I don't know, had a meg of RAM or something incredible. So times have changed since then.
That's quite good. It doesn't sound like you're that much older than me, actually, based on your answer. But where do you live, and what do you do for a living?
I live on a lovely little island off the south coast of England called the Isle of Wight, which nobody has ever heard of except it's mentioned in the Beatles song When I'm 64. But other than that, it's pretty unknown. It's kind of a holiday place. I guess the nearest equivalent in America would be something like, I don't know, Martha's Vineyard or something like that, except not as expensive as Martha's Vineyard. And what I do for a living is I do computer programming, F# consulting, and a bit of C# consulting if I need the extra money. And I'm in the process of writing a very long, delayed, procrastinated book, which I hope I can sell for a few pennies at some point. But basically, I imagine what most of us do is just basic programming stuff for a living.
Very nice. And your F# Works, is that the consultancy that you're?
Yes, we have a consultancy with me and Thomas Pettercheck and Matthias Brandwinder and Phil Trelford, and we are trying to position ourselves as F# consultants. So if you need some F# consulting or your business needs some F# consulting, please send them our way. That would be great. And we also do trainings, and we do, you know, all the usual things that consultants do.
So how did you initially get started with F#?
Well, I've always been a language junkie. Even when I was the next language I learned after DBase, or the first language on my own computer was actually Smalltalk. And then there was Smalltalk for DOS, believe it or not. Then I was into Turbo Pascal and then Turbo Prolog, and then I used Icon and Modular 2, and I always like Forth. I always like lots of weird languages. So, you know, when I was doing kind of mainstream development, I was first of all, I used Python for a long time, then I used C# for a long time, and I was like getting a bit bored of doing C#, and it's like, you know, time to learn something new, and I wanted to learn functional stuff, and look, right on the desktop, it was already installed. I didn't even have to do anything. It was just sitting there. and there was F sharp, and it's like, oh, this is cool. And of course, the first time I used it, it's like it just didn't make any sense whatsoever. I had no idea how this code worked or what it was doing. So it's definitely a learning curve there. But it was fun. I really enjoy learning languages. That's actually one of my, it used to be one of my hobbies. So definitely, that was definitely a worthwhile thing to do.
Very cool. And what is your favorite F# open source project and why?
Oh, I don't think there's an answer to that question. There are so many good ones out there. I mean, Fake, where would we be without Fake and Packet? Thank you, Stefan, for those. And there's libraries, the great libraries like F#X and the F# Core and all the other ones. And then there's, Ionide, and then there is, I'm going to forget some, it says F# formatting and compiler services, and there's so many good things. It's a fantastic, very vibrant open source community, and that's one of the fantastic things about F#. It's like it's really a model of what an open source community should be, I think.
Fantastic. Thank you for that list. It seems like everyone so far has a list, so they can't pick just one. But
I think it's unfair to pick one. And well, first of all, because one of the things about it, it's an ecosystem, isn't it? It's not just one library. It's the whole point. If you need the ecosystem to be useful, you can't, just having one library is useless. But having a whole ecosystem of libraries, which not only are they good in themselves, but they fit together very well. The combination of all these libraries, and the Azure stuff and everything, in fact, you can, and type providers, of course, you can just knock up something, with a build script and a NuGet thing and a type provider and deploy it to Azure, and, the whole thing. Yeah, Suave is another good one. You can just knock together projects very quickly because the whole ecosystem is great. And
aside from F#, you've mentioned a few other languages. Which languages do you happen to either use or like? That you deal with on a regular basis?
Well, I really like Python, and funnily enough, I actually kind of dislike Ruby, but I've been using Python for a long time, and so when I came to F#, of course, the white space thing was not a problem if you used to Python. I think Python, especially the earlier version of Python, had a very simple model. Everything was basically a dictionary. And I like that. You could totally predict how the code is going to behave. I think the newer versions of Python's suffering a little bit from complexity, And my all-time favorite language is Smalltalk, which is just the most awesome language ever. For many, many reasons. First of all, again, it's super, super simple. The model is super, super simple. It's got a fantastic development environment, and it's also been incredibly influential. I think everyone should learn Smalltalk just to expand their mind. Also, everyone should also learn Lisp and Prolog and Forth. I think everyone should learn like one language from each of the major types of categories of language, because most people, they know C# and they know Java and they know Ruby and they know Python. They're all basically the same language, or JavaScript. You really need to stretch your mind. You learn Prolog or you learn Forth. It's a completely different way of thinking. So,
excellent. And last question: who in the F# community should people know more about?
That is an unfair question as well, because there are so many good people, who are really working hard. And there's a lot of there's the people who you see all the time on Twitter, and that's nice. There's a nice presence there. I would say the only thing I would say is Sergey, who does F# Weekly. I think everyone knows about him, but I think even though people appreciate him, I think he needs even more appreciation, because F# Weekly is basically the place to go to find out what's going on, and to find out what cool projects are happening that you might have missed otherwise. So I think that's a labor of love, and I just want to make sure that he feels appreciated for doing that.
Excellent. Thank you, Scott. Thank you for this interview with us. And now I'm going to hand it over to you to do the presentation. Hopefully everyone now knows a bit more about you, and will feel excited and open to reaching out to you if they need any help with training or consulting with F#.
Great. So I hope everyone can see my screen. There is a GitHub. I put this code up in GitHub if anyone wants to download it and play along, or play along afterwards. I thought what I'd do is just give people a sort of an insight into the practical things involved in dealing with functional code on a day-to-day basis. As we know, we see all the libraries and we see all the new, the cool techniques like monads and computation expressions and type providers and stuff. But there's not that much on actually just the grunt work of how do you code on a day-to-day basis. So I thought what I'd do today is show you some kind of ugly F# code and show you how I think I would improve it, or how I turn it into at least something looking a bit more functional. So I have this README on that page there, and these are the basic standards things that I think we all know. The first thing which is different from OO is that you separate the code from the data. So you have your data types and you have your functions, and they are not the same place. This is an important one. Every function has an output. If you're dealing with OO code, you do with a lot of mutable state, and you have a lot of functions that don't actually return anything. And that makes it very hard to glue them together with piping or other kinds of composition. So just if you bear this in mind, that every function has an output, that's actually quite a good tip when you're trying to write functional code. And then the other thing, of course, is there should be no hidden side effects. And you can still have side effects, but just make them obvious rather than secret, So here's some guidelines I like to use. Composition everywhere. So gluing things together, gluing small things together to make big things. That's sort of the secret of composition. And sometimes the things are in different levels. Like you might have some things which are options and some things which are lists, and some things which aren't either of those. And so there's this concept called lifting, where you basically lift everything to the same kind of thing. So if you turn everything into an option, and then you can work with options, or you turn everything into a list and you can work with lists. Parameterize all the things. So if you do have these dependencies on global code, like either other methods or something, rather than hiding them inside the function, you basically pass it in as a parameter. And that way, again, it makes extremely explicit what you're doing. Now, sometimes you end up with hundreds of parameters, and how do you deal with that? Well, that's a whole other question about, dependency injection and so on. But it's better to have to be more parameterized than not parameterized enough, I think. There's no problem that can't be solved in wrapping in a type. We're using a statically typed language, and basically, types inside of types inside of types. It might affect performance. I wouldn't necessarily recommend this if you're doing, super duper performance related stuff, but for most kind of business domain stuff, it really is not going to cause a problem, I don't think. And then finally, modeling a program like a compiler. So rather than think in object-oriented world, we tend to think of message passing. I send a request, I get a response. In a functional program, basically you have this model where you have some sort of untrusted input, and you parse it into something that's some sort of trusted internal representation, which is your domain. And that's where you do all the error handling. It's like, is it this string null? Is this string one of the values in my enum, whatever? Once you've got it into the trusted internal representation, you can process it any way you like, do all the business logic. And at the end, you send it back out to the untrusted world. You basically transform these domains back to strings and ints or JSON, whatever it is. But the nice thing about it is just in the middle step, you never have to deal with nulls. You never have to deal with anything that can possibly go wrong. So your error handling is much more controlled. You basically do all the error handling at the parsing stage and forget about the rest of it. So there's a bunch of tips here, but I think what I'll do is I'll just dive straight into the code now. So what I've done is I actually couldn't find any good F# codes as a target for refactoring, because it's all absolutely fantastic, of course. But what I did do is I thought, well, I'll take some C# code and I will convert it into F# code in a one-to-one fashion with mutables and everything, and then I'll refactor that. So for example, here is a class that came from something on GitHub, and this is a C# class that basically does a guard. So it tests, is something not null? If it's null, it throws an error. This is if it's not null or empty, it throws an exception. If it must be less than this value, it throws an exception. So there's all this kind of stuff going on. So let me show you how the equivalent code would be written in F#. So again, I have a class. I have static members on the class. I have a default argument here. I've got all these horrible exceptions being thrown, and more horrible exceptions, and lots of all these horrible exceptions. So how would I refactor this to make this? First of all, we'll see in a minute that you can actually get rid of this altogether. But if you did have something like this, how would you make it a bit more functional? Well, the first thing is that since these are all static members, you can basically make them into a module and make everything let bound things in the module. All right. So that's the first thing. I'm going to see if I can just get these open side by side. Vertical tab group. That might be a little bit. So that's the old code. And this is the new code. So there's the old version of that function. And here is the new version of that function. So it's, there's no way really to make this simpler. Just want to point out that F# has a bunch of things for throwing standard exceptions. So rather than raising a null argument null exception, there's a built-in function for that, null arg. There's 4 built-in functions. There's null arg, argument exception. There's fail with, which is a generic exception, and there you go, invalid arg. That's the other one. So that's one thing you can do. But here, look at this one. We keep talking. Here's the thing that uses is null or white space. Here's another one which uses is null or white space. And there's quite a lot of stuff where you have these things that you keep checking for, and it's quite common in C# code where you have like, if it's this, do that, and if it's this thing, do that, and if it's that thing, do that. One of the things it's nice to avoid is a lot of kind of nested ifs. Not that ifs are always bad, but if you have a lot of them, it's probably better to use pattern matching. Well, the problem is you can't pattern match on this because that's a function. But what you can do is create an active pattern like this over here, which does the pattern matching, which does that function for you. And then you can actually use this in the pattern matching. So, here, if it's null or white space, I'm returning this special kind of value, otherwise it's nothing. So in my code here, here's the original version. If it's null, do this, and if it's white space, do that. I've now got a pattern matching. If the target is null, throw a null argument. If it's null or white space, throw an invalid arg. And one of the things about pattern matching, which is really good, is because it's exhaustive, you are forced to handle the edge cases. So one of the things about the C# code is it's like, what happens in, have I forgotten something? And it's not at all obvious from these nested ifs whether I've forgotten something or not. But here it's very obvious that some non-null value may indicate a case covered by the pattern. So I'm going to handle all cases. And I'm explicitly handling the case where it's true, where it's okay. So that's just a nice thing. It's a kind of sanity check to stop weird edge cases from happening. And then there's a whole bunch of ones here now where is it less than something? Is it greater than something? Is it greater than or greater than equal, less than equal? These are all basically the same, and they all throw exactly the same exception, which is an argument out of range exception. And so when I see duplicate code like this, what I like to do is parameterize it. What's the same and what's different? Well, what's the same is this whole kind of logic. If it's something, then raise this exception. What's different between each of these ones is this predicate here. Here I'm comparing less than equal. Here I'm comparing less than here and less than equal here. And here I'm comparing max. And then what's also different is the error message in each case. All right, so let's look at the F# equivalent. Well, because they're all exactly the same, what I can do is parameterize it. So what I'm going to do is create a function which checks the range. It's got a predicate, it's got a message, it's got a value, it's got a parameter name, and if the predicate passes, then I throw the exception. So it's exactly the same as the C#. It's now parameterized on a function. And I could have done that in C# too. I mean, or the person who wrote this could have done that, but it's very unusual that you'd pass in a func or an action. Typically, you just repeat the code because it's too much hassle. The nice thing about F# is, of course, I don't even have to define what type it is. I don't care what type it is, really. If I hover over it, it says it's going to be a predicate that returns a Boolean. But you know, I don't. It's just I just put the parameter in, parameterize all things, put the parameter in, put the parameter in, use the parameter, and I don't have to care that it's a function or anything. So then the rest of the code, I define the predicate, I define the message, and then I do the range check. And in this one, I define the predicate, and I define the message, and I do the range check. So basically, the complicated part has been refactored out. So this is like a method refactoring, or extract method, I guess you'd call it. One other little thing I should show you is that in the C# code, there's this type constraint. It's a generic, and the generic has to be a comparable. And in fact, in the C# code in general, these type things is just really horrible. There's a t-value where the t-value is comparable, and it's a t-value. It's a comparable of t-value, and the first thing is a t-value, and the minimum is a t-value. And of course, you don't need all that F# will infer it, but it won't infer the comparable. So I am explicitly saying that. But one nice little trick is, rather than saying that it has to inherit from a comparable, there's this little hash comparable. So that's a nice way of, especially for things like interfaces like disposable or comparable or equitable or whatever the other ones are, that they are the standard ones. So that's a nice way. And once I've defined that there, then the whole function gets that for free. So there you go. So that's makes this whole thing quite nice. That's basically 82 lines of code. And that's not much shorter than the C# version, but it is a little bit easier to understand. So that's one kind of refactoring. But let's look at a way where we don't even need all these tests for not nulls and so on. So I'm going to go over here, and this is something. Where is it now? Yes, and I'll open up this one. Let's remember. Whoops. No, okay, that won't work. I think this is more trouble than it's worth, actually. So this is something from Vaughan Vern's book on domain-driven design. And in his book, he uses a kind of Scrum or project management system. He shows how to design a project management system using domain-driven design. And one of the things is something called a member or a team member. And they have a name, and they have a username, and they have a first name and last name and an email and all these various things. And this is the kind of code that you write over and over in C#. So you have some sort of constructor, and you assign, in the constructor, you assign everything to properties. And this change tracker thing I'll talk about in a second. And then, of course, all the properties have getters and setters. And on the setters, you need to make various assertions. So you can't set a username to be null or empty. And if you do set it, it has to be at least 250 characters. And the only problem with this is that once you're setting a value, there's no way to convey that the setter doesn't work other than throwing an exception. And so as a result, this is a unit method. This setter returns nothing because it's mutating the internal structure. And as we said, those are bad. Things which return nothing is always bad, and things which throw exceptions, that's it's hard to know what's going on. So basically, this is kind of, from an F# point of view, this would be kind of ugly. kind of code, and it would be nice if we can get rid of it. Well, how can we get rid of it? The way I like to do it is to basically pass the buck to the caller. So rather than you testing whether the value is null and whether the value is the right length, you create a type that has that built in, and then the user, whoever's going to call you, has to create one of those types. And then when you get it, you never have to, because that type is created in such a way that the constructor, you literally cannot create a type which doesn't have a value which doesn't have the right properties. On the setter, you don't have to do anything. You know that if it's a first name type, it's going to be the right length and it's not going to be null. And then you don't have to do any validation on your end. The caller has to create it. So if we look over here, so this is the F# version of the same thing. And notice every time you see mutable, that's a big code smell in F#. So we can see if we can get rid of that. Every time you see a Boolean, this is a code smell as well. Chances are, if you have a Boolean flag in your data structure, there's some sort of state machine going on. And as a result, you really shouldn't. Chances are there's things you can do when it's enabled that you can't do when it's not enabled. There's probably some method somewhere, and in that method it'll say, if the enable's true, do this. If the enable is not true, do this. That really means that they're really two different states, and they should be modeled with two different types, and then I use a union type to connect them. So I show you that as well. And finally, this change tracker. This change tracker is a way of keeping track of, let's show you. Let's say that I want to change the email address. This change tracker keeps a track of the timestamp the email was changed. So if the email was changed more recently than the current date that you're passing in, then it won't allow you to change it. And that's basically to stop you overriding data. It's kind of an optimistic concurrency kind of thing. And the same thing if the email is different. So only if the date is newer and the email is different, can you actually update the email address. And if you can update the email address, then you mutate it and you create a new change tracker. But again, there's a lot of problems. This does not indicate at all whether the change actually happened or not. So if I'm trying to, only if I successfully change the email and I want to store it in the database, I only want to restore it in the database if it was changed. If it hasn't changed, then there's nothing to store. So I really want to know whether the change was successful or not. And this method, unfortunately, doesn't tell you that. It's one of these unit methods that returns nothing at all. So let's see if we can solve both of these problems. So this is this is F#, but this kind of looks like a very imperative F#. Let's look at what the more functional code would look. So I've got some helper classes just to make the code compile here. So what I was talking about, getting rid of the validation, what I'm going to do is I'm going to create these classes or types, string 50, string 100, string 250, and these things cannot be created in an invalid state. So if I try and create a string 50 and I pass in another empty string, I get a failure. And if the string's longer than 50, I get a failure. And otherwise, I successfully create it. And the same thing for all these, 250. And then I can actually say, well, the username is a special type and it's a string 250. Or a first name is a string 50 and an email address is a string 100. So it's not possible to create an email address that does not, that is empty or has too many characters, which means that when I'm trying to do the inserting here, this insertion doesn't make sense. It's not even possible for the thing to have the wrong number of characters. So I never have to check whether it's null, and I never have to check whether it's the right length. So this code basically disappears, which is nice. Just checking, can you hear me, Ryan?
Yes, I can hear you great. And
Okay.
I've been looking for questions, but so far there are no questions. If you have questions for Scott, please do use the Q&A feature or send questions on Twitter, and I will be sure to quickly jump in and ask them on your behalf.
Great. I'm just talking away, and I'm just making sure that I'm not just talking to a blank wall. Okay, so here, what we're doing here is we're defining all our types, and we're defining a new little small type. There's something where in the original code they didn't bother to create this type. Probably a bit too much work, really, just to create a type just for that with 2 fields. But it's really easy. And then here's my member type. Now these are nice and immutable. I don't have to create properties for them. I don't have to create any kind of validation. And here is an example of what I was talking about. So here I don't have an enabled flag anymore. What I'm going to do is I'm going to say a team member is either enabled or it's disabled. And right now I don't know enough about the domain to see what the difference is, but I'm guessing that there's a reason why they want to keep track of what it is, because they might have functions that only work on enabled things or disabled things. So I'm representing that with a discriminated union. So there's my domain.
Scott, we do have our first question.
Yes.
Mark Gray is asking, how do you prevent people circumventing your factory functions?
Okay, so actually I have, for how to make the constructors private, see this gist here. And it's, if you go to my, if I go back to the, I'll just show you on the README. If you go to my, my GitHub, there's a project called Refactoring F#. And if you go to this piece of code here, which is called member FP, you can see how that works. And I'll put it on the main thing too. But basically, you make the constructors private, like this. I'm not going to bother to do this for this example, but it's if you make them private, then you have to. There's a little more extra work you have to do in order to get the data out, because nobody can see how that type works anymore. And there are other ways of doing it too, but that's a good question. Mostly, you have to decide, do you really want to, how much trouble do you want to go to make them private? I think that conceptually, I think is the important thing. If I have a string 50, I shouldn't just create a string 50 randomly. I should use the defined constructor here. So I hope that answers the question. All right, so here's what's nice about separating the data from the functions is that I can see the entire domain on one page like this. There you go, pretty much the entire screen. And that's pretty cool, including the fact that this, the first name is only 50 characters and the email is 100 characters. If you go to the C# code, you can't actually see there's no single place where you can see how the entire data structure is created. And in particular, you can't see all these validation rules. They're kind of buried in the middle of the setters, the property setters. And that makes it really hard to see, what's going on. So I kind of like the fact that everything's in one place. So all the setters then in the C# code, we had to have getters and setters. We don't need to do that because we have immutable structures. In the C# code, we have to have validation code here on the setters. We don't have to do that because it's literally not possible to set the username to be a non-valid string. So we're basically passing the buck. Now, how do I get a string 50, or how do I get a valid email address? Well, that's not my problem. You're the caller. You figure it out. You give it to me, and I don't have to worry about doing validation. It's not my problem to validate your code. So this is what I was talking about: the separating the kind of untrusted data from the trusted data. The untrusted data, this may originally come in as some sort of JSON object, and everything's just a string. You'll have to try and create one of these things. You'll have to create one of these things from a JSON object. But once you've created it, you now never have to do any null checking or any kind of length checking anywhere in your domain. So the fact that you have this kind of stuff going on in the middle of your domain, that means you basically don't even trust the data that's being passed around between types in your domain, in code. Your domain should not have to worry about whether it can trust somebody. If you're doing this kind of defensive programming inside your domain, I think that's a bit of a code smell. Yeah, you need to be defensive when you're actually getting data from the outside world. But once it's in the trusted world of your domain, you shouldn't have to ever check it again. All right, so let's look at this thing of the changing email address. So the logic was in here that if the date you're trying to change it is newer and the email you're trying to change it to is changed, then you can successfully change it. Otherwise, you can't change it and it's unchanged. And here in the C# code, or in the F# code, it's really not very obvious. I mean, you have to write a special method called can change email address. It's really not clear what this change tracker thing is. Quite a complicated object just for doing one little thing. I personally would stick it right in your code like this. You know, make things explicit. It's not that hard, and it makes the logic really easy to understand. If the email address has changed before this date, and the email address is different from the new one, then I create a new structure, and I return something, meaning that something changed. And if nothing changed, I want to indicate that, so I'm going to return none. Now you could change the design to return the same thing, like just return the member, return the new member info on success and return the existing member info if nothing happened. But I'm assuming that somebody else wants to know whether something's changed because they want to update the database or they want to show it on the screen, or I don't know. But it's very weird that you do a bunch of stuff and then you wouldn't actually indicate what you've done. So this is another thing that I think is a code smell. If your functions don't indicate what they're doing just from the type signature. So you probably can't see this because it's a bit tiny. But what this says, this type signature says the change email addresses. It takes an email address, it takes a date time, it takes a member info, and it returns an optional member info. So it's very clear that it returns a new member info, so something's changed. And it also is very clear that it might not return anything, which probably implies that nothing's changed. You could make it more explicit. You could have a special type called, changed member info versus an unchanged member info. There's various things you could do, but I think having the signatures indicate exactly what's going on is a very nice thing about functional programming. And having signatures say, I take a bunch of stuff and I emit a unit. It's possible to say, well, what am I doing? Am I throwing an exception? Am I updating a database? It's really hard to say what's going on. So all these ones are much nicer, I think. And here's an example of the disabling function. So the disabling function only works when it's enabled. So if it's already disabled, nothing happens. If it's enabled and the new date, if the date is newer, then you can say, yeah, it's now disabled. Otherwise, again, nothing happens. So I think it's actually easy to understand what's going on with this code. Not only is it the function signature clearer, but it's actually easy to understand. And then finally, we have these two types here. We have this member info here, and we have this kind of type here. Now we have these functions that work with this thing, like changing an email address. Now we might have one of these things, and we want to change the email address for one of these things. The functions we have don't work on these things. They only work on these things. So what we need to do is turn a function that works on these things into a function that works on these things. And that would be the lifting function or the mapping function. And all you have to do is write one of those maps for each type, and it's nice and generic. It will work with any function. So for here, I've got a function, a thing called map. It takes any function, and this is a function that turns member infos to member infos, and it basically lifts it into a function that turns team members into team members. So I can take any member info function and convert it into a function that works on these things. So I don't have to write a whole bunch of, special check in this case and check in this case. So that's another sort of a bit of a code smell. If you're doing a lot of matching against things all the time, chances are you can write a function that will do that for you. I see this a lot where people write they're matching with some and none in options all the time, and there are already option functions that will do that. There's option map, there's option bind, there's option iter, there's option filter. I think there's a lot of functions already in the standard libraries. I would say learn to use them. If you, like I say, you should only really need to use matching once or twice basically to set up those functions. But when you're actually doing the business logic, you shouldn't really have to do all these switches all the time. All right. And then I just want to show you the constructors here. Here is how to create a tenant. So I'm going to pass an integer. If the integer is less than 0, that's a failure. Creating a username, creating a first name, and so on and so forth. This is an example of using a map. So this basically creating a string 250 that might succeed, it might fail. If it does succeed, I want to create a username. If it fails, I'm just going to turn the failure message. And so I need to pass in a little function, and this will always be a success in this case. And then I'm going to take this successful string and I'm going to wrap it in a username. And in fact, what here is this is F# Power Tools, the linter, telling me that I can actually replace this entire function here with just the constructor. So this is the kind of ugly version, and this is the clean version. And here's another one where for email addresses, I'm doing a bit of extra validation. So assuming I successfully got a string 100, if it contains an @sign, that's good. I've got a successful email. And if it doesn't contain an @sign, then I have an error message and so on. And so on and so forth. And here, yeah, so I'm not going to go too much. You can read all about this in the railway-oriented programming talk, which I think you might be familiar with. If you're not familiar with, there is the link. ROP, F# of Fun and Profit /ROP. There you go. So that will tell you everything you know about that process. Let's actually just test this. So let me just load all this stuff up first. Let me open up make sure that this is bigger. So I'm going to create 2 timestamps, 1st of January and the 2nd of February. And then I'm going to create an email result. So this one was successful because this one is an email, and it's say I successfully got an email address. This one doesn't have an @sign. So if I try and create it, I get a failure. So no exceptions, no weird stuff. And then here's the same thing. I can combine all the different things. I'm creating a member info, and this is a successful member info. But here I've got a bad tenant ID, it's a 0. Here I got a bad email. So I'd expect to get 2 errors back. And there we go. We get the tenant must be positive and the email must have an @sign. And so, you know, I'll go into, don't want to go into too much detail, but that's just to show you how you can handle errors and how you can do these nice, very strict domains and still keep the code easy to use. Right, let's do another one. Okay, so another one I found was a JPEG decoder. And here we go, it's the same kind of thing. It's basically something that reads an image and it turns it into a JPEG file, or vice versa, I can't remember which way around. But this is typical kind of C# code. We have, we need to check that the input is null or empty. We're going to see, well, does it have a dot in it? And otherwise, we're going to take the first thing. And then if the extension is one of these things, we're going to do this. And this whole function is a Boolean function. And again, if you have Boolean functions, that's generally a kind of code smell, because rather than returning a Boolean and having somebody else, when you've returned a Boolean, you've just reduced everything, the whole world down to 2 cases. And so the person who's going to be consuming that Boolean has no context. Much better to try and, rather than have a Boolean, is like pass a function into this thing. You pass an extra function here, and it's like, well, if it can do this thing, then call this function. If it can't do it, then don't call the function. But you now have the complete context for knowing whether that function should be called or not. And the Boolean context, you know, you often throw things away. And often you find that the code, you end up with a kind of duplicate code because you test something and then you get a Boolean, and then you need some extra context, so you do something else. I mean, a good example is in C#, if you want to process a list, you might say, well, is the list empty? If it's not empty, get me the first element. Now, in F#, you would just use pattern matching. You'd say pattern match on the empty list and pattern match on the first element. And you don't have to like do things twice. The thing happens in one single step. You get the pattern matching, you get the testing, and you get the assignment to the various pieces in one go, which is why pattern matching is nicer than all these if then else's, because the if then else you're just working with booleans and there's not a lot of context there. All right. What's next? Yeah, so there's a bunch of, is it a supported file format? Here's another bunch of booleans. And there's another unit, there's another test. Oh, here's a nice mutable. This is a very kind of common thing. There's some sort of mutable and there's like some thing, and then inside that thing you assign that mutable, and otherwise you don't return it, and so on. All kind of typical things. And then to decode, we're going to be doing
quick question, Scott.
Yes.
Back on that mutable scenario you were just showing above. Is it really much of a problem since the mutability seems to be contained within that one member?
It's not a problem, but it does mean it's a chance for bugs, because if I accidentally comment out this code, there's no compiler warning. So the problem with statement-based approaches like this is that, I mean, obviously this is really obvious that I've commented out this particular case, but in a more complicated scenario, it's quite possible that you have some sort of complicated if statements and you actually forget to assign the mutable that you're trying to return. And you end up never assigning it and you return false or you return 0, whatever it is. And the compiler's not going to give you any help. In an expression-based language like F#, you can't do that. Every single case has to result in a value. So, you know, in F#, the if statement is not a statement; it's actually an expression. So the if bar, this actually returns something. So if I actually had something like this in F#, it would say there's like, you know, I've got a bunch of things, but nothing happened. Nothing comes out of the if branch, and that would be a compiler error in F#. Much to people's annoyance, of course. You know, it's like, well, how come my if then else is, you know, giving me a type mismatch? Typically, it's a type mismatch because it assumes that you haven't assigned anything, therefore you want this to be unit. And you say, well, how come this is returning unit down here, and this is a Boolean? And it's like, is it a Boolean or a unit? What do you actually want? So you have to be able to recognize in if then else that the unit case means that you've forgot to handle something. So. Yeah, so I'll have a look at how the F# code works. I'll look at the same thing in F# in a minute. So here we go, some typical things, a bunch of tests. Now what we're going to do here is it's going to loop through all the pixels and do something with all the pixels. And it's going to do it in a parallel for loop. That's very nice. Have a look at this code. Okay. And just kind of don't try to understand it, but just have a quick look at it. Now, in a different situation, when you have a grayscale, have a look at this code. Can you see the difference between the two codes? Well, there's a subtle difference. There's actually, this is the difference. There's just a couple of lines difference here. The problem is that there's so much duplicate code here that you lose track of what's the important stuff, and you know, you focus on the boilerplate and you forget of what's the actual. This is the really important stuff. The rest of the stuff is just the same. This is exactly the same code. So let's see if we can actually refactor that code out and make it allow us to focus on what's different between these two cases rather than what's the same. And here is another one. This is testing the tag in the header of the file. So if the bytes 6 to 10 contain GIF. That's or JFIF. If the first bytes contain Exif, that's a different kind of header. And this code looks awfully similar to this code as well. I wonder if we can parameterize out the common code. And this code looks awfully similar too, but it's not quite the same. But anyway, so let's look at the F# version here. So this is the F# thing, and it's exactly the same. I've got all these guards, I've got this, everything has to be mutable. I have to have this. It makes it very clear when I made the F# version of this code. In the C# thing, everything's mutable automatically. You know, you don't have a special keyword. In F#, it makes it really obvious that you've got mutability. If I just said this, you know, I get a compiler error straight away. They're just not happy. So, you know, it forces you to stay honest. Okay, so that's the kind of imperative version. Let's look at the functional version. So one of the things I'm doing is I'm going to separate the, I'm going to put everything in a module again, because these are all functions that work on images. So why not just have a module? All right, so let's look at the first thing up here. So here we have this thing where we're doing this string comparison with an ordinal case and string comparison with an ordinal case. And so this is begging to be turned into an active pattern. So let's do that. Here's the F# one. I'm going to say, is it equal in case insensitive equal? And I'm going to do that little work. But then what I can do is I can just say, if it's null, do this. If it's equal to PNG, do this. If it's equal to GIF, do this. And if, you know, whatever. So the code just looks much nicer, I think, compared with the other code. Let me see if I can get this back. Yeah. So there's this, the one on the right hand side is the old code, and the one on the left hand side is the new code. Now the other thing is that this is mixing up the kind of business logic with the parsing logic, like I said, with the compiler. What I'd like to do is, this is obviously some sort of untrusted string, because I have to check whether it's null or anything. What I'd like to do is turn that untrusted string into a trusted value. So what I'm going to do is actually create a new type. Like I say, all problems can be solved by creating a new type. And so I'm going to create a type called file extension. And these are all the file extensions that this application is going to understand. And anything else, I'm just say, I don't know, an unknown file extension. So I'm going to break this function actually into two pieces. The first piece is going to turn this untrusted extension string into a file extension type, a domain type. And that's where it could return an error, or it can, in this case, I'm just going to return unknown, but in some cases you might return one of these result errors, or, you know, option or whatever. So that's the first thing. And it's not doing any logic at this point, it's just parsing the input. Now the second part of the logic is like, if the extension is one of these three things, then I can do something. So that's business logic. And what I'm going to do here is now have a separate thing. Is it a supported file extension? And now, because I've done all the parsing, this thing can never be null. This thing can never be some weird string that I don't know what it is. It's going to be one of these cases always, because I've already parsed it into one of these cases. So by separating the parsing logic from the business logic, I've made the code a lot more maintainable, I think, because this stuff might get, the parsing code is generally pretty ugly, because you're always dealing with nulls and missing values and stuff. But once you get into your domain, this is very straightforward. Notice I'm returning a Boolean. I think this is a bad idea, like I said, but I'm just copying what the the original version had. The other thing I'm doing, you'll note that I'm not doing this. I'm not using a wildcard. And the reason is that wildcards are generally a code smell as well, because they'll match anything. And the problem with matching anything is that when you change something later on, you might have a new bug. So for example, I'm going to come along and we have a new file format that's the trendy thing, and it's called JPOG. And you know, I can parse the JPOG file format. That's really easy to do. But when it comes down to, do we handle JPOG? It's not on this list, and it'll say, no, we don't handle JPOGs. And that's probably not what I meant, because I really wanted a warning. This is a whole new kind of file type, and I really need to decide what to do with it. Well, maybe we don't handle it, but I want to at least be aware of that decision. If I'd gone back to the original design where I had listed all the possible cases in my thing, then when I go over here, I actually get an error, or a warning anyway. It says incomplete pattern matches, for example, value JPOG may indicate a case not covered. So as it happens, maybe JPOG is something I do want to handle. The point is that the compiler will tell me that I forgot to deal with it. So having explicit cases is always better than having unknowns. Sometimes you have to have a wildcard if you're dealing with integers or strings. You often you don't have a choice, but that's why, like here, I have to have a wildcard because any string could come in. So I have no choice but to have a wildcard. But this is where the whole point of separating the parsing logic from the business logic. In the parsing logic, you often have to handle weird strings and weird ints or whatever. But once you get to your domain, it's very unlikely. You shouldn't have to do that. So if you go back to here, is it a supported file format? Oh yeah, so another problem which pops up all the time when you're porting code is this, these functions or these methods are below this. This whole thing is at the top of the file, and these are not above it. They're actually below it. They're all the way down at the bottom down here. And that's fine when you have members, because members are not order sensitive. But when you have let bound functions like that, these things will not be found. So you basically have to make sure the ordering is in the right order. So in F#, I'd basically have to take these helper functions and stick them above this function. And sometimes you get circular dependencies when you do that. And there are ways around to avoid that. And I have a blog post about that. Hopefully it won't happen too often. The important thing is just to get the order right. So let's look at this one again, and let's see if we can tidy this up. So what I'm going to do is, rather than having a special Exif function and a special JFIF function, I'm going to, write my own little function. So what I'm going to do is I'm going to pass in a header like this, and I'm going to pass in the tag, which are these bytes down here, and I'm going to loop from this, from the starting point to the length of the tag, and if the elements are equal, I'm going to keep a track of a flag, and then if they're all equal, I'm going to set this mutable. This will be true to start with, but if any of them are not equal, then it'll be false, and that will fail badly. Let's see if I can run that. So there is my Exif tag. By the way, here's a nice little tip. If you want an array of bytes from a string, you can just put a big B at the end. Very cool. So there's my header. And then does that header have that tag starting at position 6? Yes, it does. There it is. And does that header have that tag starting at position 3? No, it doesn't. So there you go. That's a more generic function. But in fact, this is a really horrible, ugly function too. It's using a mutable. It's using some sort of looping thing. That's kind of smelly as well. Here's a much nicer way. What I'm going to do is I'm going to take the subset of the header from this range, and I'm just going to give me a new array, and it's going to compare the two arrays. So there's the length of the tag. I'm going to take the subsegment using this array sub function, and starting from this point and going to this point. So now I have a segment, and I have the tag, and I just compare them. And that's a lot cooler, a lot easier to write. One of the things you notice that in this version of the code, I explicitly said this is a byte array and this is a byte array. A bit of a, if you have to always put annotations on your types, chances are, again, that you're not being as clever as you could be. So for example, here, I don't have to say it's a byte array. I'm just, by saying array length, it knows that this tag is an array. And by saying array sub, it knows that this header is an array. And in fact, it's not a byte array anymore. It's actually worse than anything. So in fact, this is actually a bad name. Header has tag. It should really be called, array has segments or something. Because actually now this is a very useful generic array method, and it's nothing to do with this particular function anymore. But it works just like the one that works too. So now, to see if it's a JFIF, there's our tag. We just say there's the header. If it's an Exif, there's our tag when we do the test. And is it JPEG? There it is, exactly the same thing, except this time we start from offset 0. And now the is-supported file format, we can just do all this in one line. We don't have to have all this mutable. That was what it looked like before. Test a mutable. If it's this, then do this and this and this and this, and then reset the mutable back. No, I can just do it in one. Everything's much tinier. I'm still guarding the header, that it's not null. How would you solve that? Well, the answer is to wrap it in a type. So I might have a special thing called header bytes, and that's a special type which contains a byte array. And when I construct that type, I guarantee that the byte array is not empty and has more than 11 bytes in it, for example. So I might say an image header type. In fact, that would make it much more self-documenting. Why don't I just do that right now? Type image header. I just thought of that. One of the nice things, again, you see, is I've got nice documentation straight away. The type signature now says that this method or this function takes an image header. So I've got self-documenting code as well. So that's kind of cool. Right, what else is there? Okay, yeah. So if we go to the decoding, and I'll just be another 5 minutes or so, I think. Here is remember, and it's got these various parameters, and it outputs a unit, of course. It doesn't actually return anything. So it's really hard to know what this thing's doing. So I like to have my functions have an input and an output. So it's very common. I imagine that all the decoding functions have the same inputs. They have some sort of image and they have some sort of stream or whatever. So I'm actually going to create a little type to represent it. So now this function is going to have a decoder input. And what's the output? The output is probably a new image or something. I mean, now the image decoding might not be the best example because you don't want to be copying giant arrays of bytes around in memory. But if I wasn't concerned with eating memory and performance, I would definitely make a copy of the original input. That's the right way to do it. It might not even be a problem. It might be one of those things where it's not as bad as you think it is. If you've got very, very large things, this is probably not the right way to do it because the whole thing's in memory. Probably a stream thing would be better anyway. And then what's the output? Well, if you look at this one, there's all this stuff about, is it supported, is it not supported? What I'm going to do is say, I'm going to return a special kind of error type. So either succeeds or it returns with an error where the decoding succeeded or the decoding failed. And it makes it much nicer to understand here. Because I think, yeah, here we go. So if the image color space is RGB and there are 8 bits component, then do one kind of thing. And if it's grayscale, you do another kind of thing. And if it's not grayscale or RGB, you throw an exception. So here you have a unit function that throws an exception. And what's interesting, so it's really impossible to tell what it's doing. One of the interesting things about throwing exceptions, I believe, in this, if I go back to the C one, is that the documentation about which exceptions are thrown are often wrong. So in this is an example where they've done very nice documentation on the header, and they say this particular thing, it can throw an argument null exception. Well, this is true. It can actually also throw a not supported exception, and that's not actually documented anywhere in the code. If you take the F# approach, and you define a type like this, this is your documentation of all the different errors that can come back. So I'm going to parameterize all these things. So where are we? First of all, I'm going to take this parallel 4 and I'm going to wrap it in a function. And here's another little tip. When you do a lot of time when you're interacting with just going to clone this out. If you're interacting with .NET, you get errors like this. So what it's saying, it's going to say in a minute, and the unique overloads cannot be determined based on the type information, because there's probably 20 different overloads for this particular method. So one nice trick is if you take the names, often the different overloads have different names. Can I bring this up?
By the way, Scott, I don't know if now is a good time for a question or not.
Yeah, go ahead.
Jamie Dixon asks, but you still need XML code comments for publishing your help. How would you do that? XML code comments on the type?
Yeah, so yes, I can put XML saying this is the error type. But if I actually look at the output, it will, the type, rather than saying it returns a unit, it will return a decoding error. Or it will return a decoding error option, or a result of, with the success case being an image and the failure case being a decoding error. I don't need documentation to tell me what the thing returns, because it's in the signature. So the very fact that it returns a decoding error, and then I say, oh, well, what's a decoding error? Oh, here it is. Here's all the things that can go wrong. It's, with the exception document, I don't need to have the documentation. I mean, it's nice to have documentation, but the documentation, is useful to tell you why it does something, but in terms of actually what it does, you don't need documentation for that, because the types tell you what it does. In the C# world, if you're using exceptions, the types, returning a unit doesn't tell you anything. So you have to have the documentation saying it returns this kind of, it throws this kind of exception, it throws this kind of exception. And again, in the XML documentation says, well, this value, this input is, here's an integer parameter, and this needs to be non-zero. And here's another integer parameter, and this needs to be a string, which is, here's a string parameter, it needs to be less than 50 characters. And here's another string parameter, and it needs to be less than 100 characters, and it has to be non-null. And, all that documentation can be replaced with a type saying, here, this parameter is an email address, and it's an email address type. You don't need, that's all you need to know. By definition, you don't need to. It's not possible to pass in the wrong kind of parameter. You don't, you don't have to have documentation for the validation. The validation is actually in the type system. So I hope that answers the question. So I was just going to show you this thing about. Here's a nice little tip for dealing with overloads. So this parallel 4 has 12 overloads, and the first one says from inclusive to exclusive, and then there's another one, and there's another one, and then there's another one with parallel options, and so on and so forth. One tip is if you give the names of the parameters, often that's enough. Sometimes it's not always enough, but often if the parameters have special names, by using the name parameter approach like this, that actually gives the compiler enough information to determine what the types are. But this is called body. It knows it's going to be that eliminates a whole bunch of overloads right away. So that's kind of cool. By
the way, Scott, Jamie had a follow-up question to his previous one.
Okay.
The XML code comments also show examples about how to use, etc. That would also be on the type or each case of the DU?
Oh, yeah, you can have, I think you can have code examples. I think you can do that. If you want to have examples, I don't know that you can have super detailed examples on the type. I mean, the MSDN documentation, for example, does have quite complicated examples. I personally would rather have an especially annotated example file. For example, what I would do, which is what a lot of the F# projects do, is use the F# formatting. You have a particular file that is your sample code, which is nicely annotated. So in F# formatting, if you put the double dot here, and you can put in the markdown you know. Some blocks, bullets, you know, and so just typical Markdown stuff. The F# formatting will actually take this stuff and turn it into nice documentation for you. So rather than using the MSDN style thing where you use the XML comments, I think this approach of having Markdown documentation, it's kind of the literate coding style where you mix your Markdown documentation along with the code. I think that's a much nicer way of doing it, because you can actually put the examples in line. I think the XML documentation, it's fine. It's very nice for having, you know, a one-line description. Like if you hover over the type, it gives you the you know, a brief description. But trying to put you know, 2,000 or 3,000 lines of documentation as a prefix, you know, as an XML thing. I don't know if you've ever tried it. I have done that, and I think Markdown is a lot easier. So I know where my preference lies. So yeah, F# formatting for the win. Definitely check it out. And it's not just the whole subsystem, but actually if you use Project Scaffold to start your F# projects off with, which is another nice open source thing, you get the F# formatting set up for you already. So that's, you know.
And I think we're about out of time. Jamie has one
Okay.
more follow-up question if you would like to entertain it.
Okay.
Any way to get rid of XML code comments altogether? They really distract from the code, in his humble opinion.
Yeah, don't have them. I'm not sure.
Well, if I may interject real fast, I think maybe another way to do this might be to have a signature file where you put your code comments for the things that you want to document there.
Yes.
As an option.
Yes, you can have it. You can have signature files as well, and that's a perfectly valid way. So okay, if we're almost out, let me show you one more thing then, which is I just wanted to show you how I could, by parameterizing all this stuff. What I've done here is taken this common code, this piece of code that was duplicated once and then duplicated twice. What was this? 2 duplications there. I put it in a thing, and what I've done here is I've just parameterized these 4 values. So all I need to do is pass in a function to get those 4 values. And then the other thing I've done is rather than having special case code with the color space is this and the color space is that, you know, again, creating an active pattern for those things. So now my code looks like this. Match the active pattern. If it's RGB 8-bit, then this is my little thing. This is the only thing that's different, and everything else is the same. And I return success. And then again, if it's grayscale 8-bit, this is the only thing that's different. Everything else is the same, and return success. And finally, rather than having an if-else thing, I just have a special thing called unsupported, and I returns a failure type. So this whole function now, from going from a unit function, it goes into a function that's very, very clear. The input is a very clear thing. It's a decoder input, and the output is a result, which might be an error or it might be an image. And I think that's probably a good place to stop then. So I hope that was useful to people. Like I say, if you're more interested, I have a couple more tips here that you can have a look at your leisure. And there's also a little file here called Tips and Smells. And I have some more little examples of how to avoid, how to use, for example, avoiding mutables and using fold instead. And I don't know what else we've got here. Yeah, so it's basically some examples that might be useful to people if they're just trying to refactor things. So any more questions from anybody?
I don't see anything on the Q&A or on Twitter. If you do have any questions, please throw them out really quickly. Otherwise, we'll be wrapping up shortly. Scott, thank you for this excellent presentation. This was really quite insightful.
Well, thank you. I hope it was useful to people.
All right, and again, don't forget. I'm still waiting to see if any questions pop up, so we'll hang on for just a moment more. Yan Kui will be on tomorrow with the F# Bristol live stream. And if you want to follow Scott or ask him additional questions after this, so supposing either you haven't had a chance to ask them or you're watching this later, Scott, what's the best way to reach you?
Twitter. If you send me a message on Twitter, my Twitter handle is @Scott Wlaschin. Very very unusual, but there you go. So yeah, that's definitely the way to talk to me.
Fantastic. All right. Well, thank you again, Scott, for your time today. And this recording will be posted shortly after we wrap up here.
Great. Thanks very much.